Before we get into privilege escalation, we'll get into what is a shell. A shell, in the most simple way, is a command line interface. So it's a way that you can type commands and the program returns output. For example, the echo command outputs just whatever you typed in there. So this is just a simple command. And this is a command line interface. So you always have commands and it has outputs. Every command line interface is text only, and the commands depend on the system. So on the Linux system you have Linux commands, on a Windows system you have Windows commands. So they differ. Sometimes there's some overlap, but they differ. So these are just some Linux commands. Windows also has a command line interface. So if I type run, search for cmd.exe, and you'll see we can type commands here. And you'll see the echo command works on both systems. On Mac you also have a command line interface called a terminal. So every operating system has a command line interface. Windows also has the PowerShell command line interface, which is a bit more powerful than the cmd.exe. And in here you can type commands as well and get output. So there's a command line interface on many different systems, not just Linux. And it basically is just input output. So you type a command and you get output. Now, using the command line, you can control a computer. So for example, we can list the files or we can see what is the current directory with the command pwd. So keep in mind these are Linux commands, so the commands I'm typing here might not work on the Windows system. So this is we're in the directory home Kali. And you'll see that's this directory. I can type the ls commands which lists the directories and folders. So you'll see it listed directories in blue and files here, which are exactly the same files. We can look in files. For example, we can type cat example.txt, which shows you the contents of a file. So in this case, example.txt. If I go in here and open the same file, you'll see it's exactly the same file, right? So in this notepad, you'll see the file contents of example.txt is the same. So basically the command line is the old way of using computers, where you just use commands and you can control the computer. And you can do everything with files. You can look into files. You can go into different directories. So for example, let's go into the downloads directory with the command cd. So cd changes the directory. And now I list the files using the command ls. And you'll see the same file. So there's one image here, one file, image JPEG. And you'll see that's the same file. Now we can go up a directory with the command cd ... And also why we just press this button. So we're back in the original directory. We can check that with pwd. If we type ls, we show again the files. Now let's go into another directory. So let's go into cd music. And then let's see which directory we are in. So we type pwd. And we're in the directory music. So if I click on music, you'll see the same directory. And there's no files in here. So if I type ls, there shouldn't be any files. And you'll see there's no output. Now you can browse around. So for example, we can just click on some directories here in the GUI. Let's say we go to the desktop. So we type cd desktop. First we have to leave the music directory. So cd ... cd desktop. And we can type the ls commands to list the files in the directory. And you'll see those match the files here. So that is the basic command line, and it allows you to control a computer. Now, of course, the more interesting thing is if we can access someone else's computer, and you can do that using a reverse shell. So a reverse shell is when you have access to someone else's computer through a terminal interface like this. So you will be able to view files, to browse around in their files, and also to edit files, because from the terminal there's many text editors as well, like Nano, like Vim, and many others. What you also be able is to download upload files, and depending on the shells you can do more things like record a microphone, start a webcam, and all kind of funny things. So reverse shell is of course the interesting part, but in order to use a reverse shell, first you have to know what a shell is, and that's a command line interface where you type commands and you get output. Linux is a multi-user system. So on any Linux system you can have more than one user, and on servers that's typically always the case. So for example, on this system you'll see there are 3 users, Alice, Bob and Frank, and all of those users have their unique password or can have their unique passwords and have their own files. So that's basic users on a Linux system. If you open a terminal using Ctrl-Alt-T, you can type who am I to see the type of user you are. And to show the logged in users you can type W, so that will show you which users are currently using the computer. So if you type who am I, it shows you your current username. If you type W, you'll see which users are logged into the computer. Now a user can log in multiple times to a computer, for example through a terminal or through a graphical interface. So sometimes the username will appear twice in the list. So as I mentioned, there are different users, can be different users on a system, for example Alice, Bob and Frank, and of course you can add more users to a system. And so if you add a user, you'll see you can add a new user with a certain username, and then there's another user in the system. So there can be many different users in a Linux system. And another user, you'll notice that there's an administrator user or root user. So on any Linux system, there's users and there's the super user or the super admin, which is always called root. So that user has complete control over the computer. And when we're talking about privilege escalation, the idea is to go from one level of privilege, so from a lower level of privilege, to a higher level of privilege. So let's say we're user Alice and we want to become root, the super user of the system, or we're user Bob and we want to become the root user, or whichever user, and the idea is to get more permissions into the system. So you already have basic access into the system as a normal user, but you want to become root. So this is called privilege escalation, and this is where you attempt to gain higher privileges or access using the existing account you already have. So you already have basic access into the system, for example as normal user 1 or normal user 2. And the idea is to become the administrator of the system, which is always called root. Another type of privilege escalation is called horizontal privilege escalation. So if you have access to a computer, for example as normal user 1, the idea is to gain access to other users which have the same level of privilege as you. You can do that in different ways, and the idea is that you can then later use any of those other users to gain root access. So the idea is to expand your access into the system. You have access as a basic user, and you either want to get access to other users or to get access as a root user, which is of course what you want, because the root user can do many different things. For example, it can reset passwords. So on Linux you can change a password by typing passwd with any name. And you'll see in order to change passwords you need to be the root user. You cannot change passwords as a regular user, at least not of any user that you are not. So for example, if I type passwfrank, I can change that password. Can change that password because I have the privileges as user Frank. But as this user, cannot change passwords as, for example, user Alice. You'll see you may not view or modify the passwords information for Alice because I am not that user. So then you could use the horizontal privilege escalation, so become user Alice or user 2, and then change the password, or ideally you become root and you can change anything in the system. So that's one of the things you can do. You can change passwords. You can edit any system file or configuration as root. System configurations are always stored in the etc directory, so you'll see a lot of files here in the etc directory, including the password file. So as a regular user, you can read the password file, but you cannot modify it. So if I open that file, that's etc password, you'll see the file is unwritable. So as a regular user, we can view which users are in the system. For example, I scroll down here and you'll see some users here, but we cannot overwrite them. So we cannot alter passwords or anything like that. So that's something you can do as root. And as root, you can also change privileges of users. So you can give users more permissions. You can install new software or remove software, or do install backdoors or all kind of funny things. So you can access basically the whole system and any data on the system. So when we talk about privilege escalation, the idea is to get more access into the system. So to go from user level to root level, or to gain horizontal access, so to get access to other users onto the system. Passwords on Linux are stored in the file etc password. If I open the file browser and I go to the Kali or the etc directory, there's many system configuration files here, and there's also a password file. So this file, and this is where the usernames are stored. So if I open it, you'll see this is where all the usernames of the systems are stored. And of course this file shouldn't be writable. But if by accident the system administrator makes this file writable, then we can use that for privilege escalation. So let's go more into the password file. So we open the file, and you'll see there's several users here. And let me just make the font a bit larger. So it should be better readable. So there's one line per user. For example, the system administrator called root is on the first line. Then the second symbol is the password. So all of the data is separated by a column. So the first element is the username. Then we have an X here. So that is the character that indicates the passwords. And the passwords are always stored in another file called the shadow file. So if I scroll down, you'll see there's a file called shadow here, which is not readable. But for exploitation, it doesn't matter. So the passwords are always stored in a hashed format. You can think of a hash as a unreadable text. So for example, I can make a hash here. So let's say my password is passwords, and it uses and let's say the system uses the MD5 hashing algorithm, then the password would be stored like this. So passwords are not stored in plain text, and we'll get more into that later. The second number is the user ID. So you'll see every user has a unique ID. The root user has ID 0, daemon has ID 1, bin has user 2, and so on. Then the fourth element is the group ID. So users can belong to a certain group. The next element is some comments, so there can be some comment here. Then the home directory, so that is the directory that opens when the user logs in. So if I open a terminal and I type which directory I'm in, so pwd, yes, you'll see that the directory I'm currently in is Kali. And let's see which user we are. We are user Kali. So let me find the user Kali in the password file. You'll see the user Kali is here, and the home directory is home Kali. So that is the directory where it always starts when you log in. So that's the home directory where the user can store his files. And final element is the command shell. So there are different shells, different command prompts. For example, C shell is one of them, bash is another. Some users have set no login, so they don't have a shell. So the last element is just the shell you're using. So that is the basic setup of the etc password file. And of course the most interesting part is the X here, which is the passwords, so the hashed words. Now to exploit it, what you have to do is to change the X here to your own passwords. Then you will be able to log in as root. Now for this exploit to work, of course the etc password should be writable. So on this computer you'll see read only here on the top. So on this computer we cannot do that exploit. But let's take a look at the computer where the password file is writable. So I have the victim's computer here in the terminal, so the command line shell, and we can type commands here and get output. Now if I type who am I, you'll see I'm currently user 1. So I'm logged in as user 1, which is not an administrator. And whichever user you are, you can always use the su command to become the administrator or root. Now in order to do that, we need the root password or the administrator password. So if I just type something, you'll see that doesn't work. I don't know the root password, I don't know the administrator password. But in this case, the etc password directory is writable. So because of a misconfiguration, if I look at etc password, you'll see it's writable. So you'll see the W here several times. That means that we can change what is inside the etc password file. And this file stores all of the passwords for this computer. Now I can output this file. So if I type cat/etc passwords, you'll see the users and the X field for the passwords. So the passwords are stored in the etc shadow field, which is not readable. Now in order to exploit this, we know that the password file is writable. So we can just overwrite the password file. And that's what we're going to do. On Linux, passwords are always stored in a hashed format. So whichever password we choose, we need to store it in a hashed format for the X value. So to create a hashed password or a password hash, we can type OpenSSL password -e -salt new and then some password. So for example 1234556. So that will create the password hash. So you'll need to remember this hash because we'll use it to replace the X for the root user which we want to be. So remember this value. So this value is the password but stored in the hashed format which Linux uses. So remember that the etc password file is writable, and now we can just write that file. So we can use an editor, whichever you're comfortable with. You can use Nano. If you're comfortable with VI, you can use that one. So we'll open that file with Nano just for simplicity. So Nano space etc passwords. Then for the X, we remove that X and we'll put that field in there. Now I'll need to type that in. So once you type that in, save the file. So in Nano you can press Ctrl O to save it, Ctrl O, enter. So that's save the file if it is writable, and then press Ctrl X to quit. So that's all. Now we can type su. We change the password for root into 123456. So this is the hashed format of 123456. Now we type su for super user and we change the password to 123456. And in this case, I made a typo. So if you type it in manually, make sure that you type the hash exactly as it is. Otherwise, it won't work. So make sure it's exactly the same as your output from your OpenSSL commands. So in this case, OpenSSL password with the password. That creates the hash. So this hash should be exactly the same as this one. Now we can type the su command to become administrator, and we just change the password. So we type 123456. And now you'll see the bash changed here. And if I type who am I, you'll see I'm now root. So I'm now administrator of the system. Now this exploit only works if the file etc password is writable. So if you see the file etc password if you see that it's writable for regular users, so the W here for writable, then you can overwrite it and immediately get access as root. So I'll show you how to solve this in the JS Linux version, so you can try it out on your own. The first thing to do is to just open the JS Linux, and this should be your output. It might be, if it doesn't work, then try another browser like Firefox or Chrome. Sometimes it might be that it doesn't work on a specific browser. So first open the JS Linux app like this. Then we need to make the computer vulnerable as if the system administrator messed up the system. So we'll open the script. So click here on the bottom, upload file. Go to downloads, select our lesson. So that's uploaded the lesson file to the computer. You'll see lesson 1 here, .sh, and we need to set it up, chmod +x lesson 1 to make it executable. And then we'll just start it with /lesson1. And then the lesson, the system will be configured by a bad administrator, so you'll be able to start hacking. So press enter. And now we are ready to hack. If you type who am I, you'll see you're currently user 1. If I type su with some password, you'll see we don't have administrator rights. But the etc password file is writable. So if I type lsminl etc password, you'll see the W's here. So the file is writable as a user. And we can output the etc password file. And of course, we're only interested in root. So the root user is in here, and we'll replace the X with the output of our new password. In order to create a new password, we use this command here. So we type OpenSSL password -1 -salt new, and then your password, for example, 123456. So that is your new password hash. You need to copy that and save it into a text file. So I saved it in a text file here, and we'll now replace the X in etc password. So the root user will replace that with the password hash. So whichever editor you want. And now replace the X with the hash here. Now JS Linux doesn't have an easy copy paste, so we'll have to type it in manually. If you use like a live CD of Linux or something like VirtualBox, you might just be able to paste it in. But in this case, we'll have to just type it in. So once you typed it in, press Ctrl O to save, and then Ctrl X. So now we replace the password with our own password, with the hash of our own password. And now if we type su with the password we just made and press enter, you'll see now the bash changed. You can type who am I, and you'll see now we are user root, so we can do anything on the system. We're the administrator now, or the boss of the system. So make sure that if you type it manually, that you type it exactly as it is, as your output. So exactly as the output of the OpenSSL command. If you don't type it exactly as it is, you won't be able to log in, because this is just the password hash. So this is the password exactly, and of course if you change one character here, then it's not the same password. Another misconfiguration is files that have the SUID flag set. So in this privilege escalation, or in this exploitation, we look for files that have the SUID bit set. So not all files have certain permissions. For example, if I type ls-l, you'll see some permissions here. So first are the user permissions, the first three, then the second three are the group permissions, and finally there is other permissions. So in this case, the user permissions, user root can read and write these files. Now there's another flag called the S flag, or the SUID flag. And this flag allows you to run the file with the same permissions as the owner of the file. So for example, if I list bin/mount, you'll see the S flag is set there. So users will be able to run this flag or the mount command as root because the special flag is there. So any user can do sudo mount and then mount any drive or use the program as root, because root is the owner of this program. Now, if some programs are misconfigured, so if some programs have the S flag set, then we can run those programs as root. Now that may not always be a problem. In case of the mount program, that's fine. But some programs allow you to give a shell, which you can then abuse. Now, in order to find files with the SUID flag set, you can search the computer using the find command. So you can type find. So let me just clear the screen first. Find. Then the directory you want to search in, for example, bin -perm and then /4000. That will search for programs with the sticky flag or the SUID flag set. So you'll see we can run these programs as root. And there is one here, the bash one. So obviously if we can run the shell, the bash shell, then we are immediately root user. So that is why it's very important that the SUID flag is not set on important programs. So if I show ls-l bin bash, you'll see the flag is set here. So that means that you can now run this program as root or as super user, because root is the owner of this file, even if you're not root. So to set any file to add the SUID flag to any file, you can type chmod +s with your file name. If you want to remove it, you can type chmod -s. So we type chmod -s and then check the file again. So now the file is correct. Now the bash file is not executable as root. However, if we do chmod +s, you'll see now any user can, because this is made by the root user, any user can now sudo this file and run sudo bash to gain a root shell. Now, this is not just for bash. There are many programs which can be abused. If you go to gtfobins.github.io, you can click on SUID and you'll find a list of programs that can be abused to get root or to read root files. So for example, if I click on the date command here, let's say date command has the SUID flag set. So let's check that. In this case, the date command does not have the SUID file set, but let's say it has. Then we are able to read any file as root. So for example, the password file or any other important file. So on GTFO-bins, you can find for many programs, either it will give you a root shell if you click on SUID, or you will be able to read files as root. So depending on which. Of course, the bash command would be very terrible, because if the bash flag is set, the special flag, any user can immediately get complete root shell access just by typing sudo bash -p. So let's exploit SUID file. So with this type of exploitation, some files might have the SUID file set. This means that the files can be run with the permissions of the file owner or group. So if you have, for example, files that can be run as root and the SUID file is set, then you can run those as root. For example, it might be the mount command, which always runs as root. But it can be that some files are misconfigured, and then you can run those files as root. And if you have an SUID binary, so an SUID program, and that has that flag set, the SUID flag, that means that you can run it as root, and some programs can be abused to start a shell. So let's take a look. We'll open the lesson 2. Oh, sorry. Lesson 2. So you'll see I uploaded lesson2.sh, I make it executable, and I run it. So now you'll see I am user 1, and what we want to do is get root. So the first thing we want to do is to find files or programs which have the SUID flag set. We can do that with the command find, then the directory, so that can be the / if you want to search all the system. You might just want to search the bin directory, and then we search for permission 4000, which means that we search for programs that we can run as sudo, as root. So you'll see here several programs that can be run as root. So the mount command, obviously, when you want to mount a computer, you need hardware access, so you need root for that, as well as unmount or umount. But also we have bash in here. So bash is obviously misconfigured. Now bash is one of those programs that always gives you a shell. So we type sudo bash -p, and we'll type the password, which is just password. That's just our user password. And now you'll see this here changed. That's because we were able to run bash as a root user. So if I type who am I, you'll see now we have root access to the computer, so we can do anything. Like for example changing the password file or changing anything in the system. We are now the root user. And all we did basically was sudo bash -p. So this is a kind of exploit that works if the permission is set. So if there is some file with the SUID flag, for example, we have these files, some of these programs, so some programs can be exploited to gain root. If you open fobins.github.io, you can click on SUID, and you can find programs that can give you root. So you'll see all kinds of programs here, which either allow you to be root, or allow you to read files as a root system. So for example, the password file. So for example, we can click on date. So let's say we run this command before and find that date is runnable as root, as sudo. Then we go on GTFO-bins to find if we can exploit it. So click on date, and you'll see UID. So in this example, you can use date to read file in the etc directory, like the password file or any other file you normally need root to read. So that is if the date would show up here, but in this case you'll see just bashes in here. There is no mount or umount, like those two programs cannot be exploited to get root. And bbsud, I don't think that's in there as well. So there's no bbsud, but however bash can be run with SUID. So as you see, if I scroll down here, you'll see the command to gain root. Now this can be for any of these programs that you can gain root or can read files as root. But it's important that you run this command and the find command. So find with the directory. You can also search in / or for example user bin or anything else. In this case I just did bin. So run this command to find if any programs have the SUID flag set. If I show you ls-l bin bash, you'll see the S flag here as well. So that means you can run it as sudo or as root. So when the S flag is there, that means that you can run it as sudo or root. So you can type sudo, in this case with bash -p. So that is just for the bash command, the sudo -p. For any of the other programs, you would have a different way to get root or to read files. And then who am I, to see if you are the root user. Now, what is the path variable? In Linux, the path variable is a variable that indicates where it should look for command line programs. So if I type echo $path, it shows some directories where it's looking for programs. So whenever you type a command, for example ls, that ls command is a program itself, and this program is stored somewhere. So to see where a program is stored, you can type where is, for example, where is ls, or where is date, and you'll see it's starting the programs in /bin. So that is the path variable. It tells Linux where to look for command line programs. So in this case, it finds ls and the date command in the /bin directory, which is indicated by the path variable. Now, how does this help you to escalate privilege? So let's say we have an executable. For example, the executable hello here, which has the SUID set. You'll see the S flag here. That means that you can run it as sudo access, so as root. So we can type sudo /hello. The password in this case is password. And you'll see this program seems to output the date command. It seems to run the date command. So what if we can change the date command to be something else? So if we type date, obviously it's showing the date. So you'll see it's running the date command, and the date command is in /bin. So what if /bin, instead of /bin/date, we make the date command execute something else? So we can do that by rewriting the path variable. So let's go into the TMP directory, and what we want the date command to start, of course, is the bash shell. So we'll type echo bin bash, and we want it to start the we want the date to start the bash shell. Of course, we need to make the date program executable. So now you'll see we made a file called date, which just runs bin bash. So if we were to start this program /tmp/date, it would then start bin bash. So let's go back to the root directory and list the files. Now if we start the hello program as sudo, you'll see it's still starting the regular date program, and I'm still Bob. So what we can do is rewrite the path variable. Now we save the program in /date. So what we'll do is export path is /tmp $path, and now we'll echo path. And you'll see the first directory it's looking for programs now is /tmp, and inside /tmp we made the date program. So now if we type date, you'll see it starts the bash shell instead of outputting the date commands. However, we want, of course, to become root, so we'll run this program as sudo, and the hello program would execute the date command, which is now replaced by bin bash. So we type, let me first show you I'm Bob. So if I type who am I, you'll see I'm a regular user. And now I'll run the program sudo hello, which will then execute as a root user. And because we rewrote the program, date, which the hello program starts, it now executed a bash shell, and if I type who am I, I'm now root. So now I have complete access over the computer. So this exploit works by rewriting commands. So if you have a program that can run as sudo and it's running some commands, you can rewrite those Linux commands to do something else, and in that way gain root. So that is how this kind of exploit works, with the exploiting the path variable. So let's solve lesson 3. The way we do that is first we upload the lesson. So lesson3.sh. You'll see by clicking here we could upload it. Now we make the lesson executable and rerun it. And after running it, we are ready to take over the system. So if I type who am I, you'll see now we are user 1. And if I list the files, you'll see there's a program here called test2, and I can list more details, and you'll see that there's the S flag here, the SUID flag. So we can run this program as sudo. So we can type sudo /test2 with our password, which is password. And you'll see the program, we can execute this program as root. And the program seems to be running the ls command. So it just lists the file in this directory. Now what if we can change that command? What if instead of ls we start a bash prompt. That is actually possible because in Linux it's using path variables. So there's a variable in Linux called path, and this is where the program is looking for executables. So for example, when you run the pwd commands or the ls commands, it's looking in these directories for those commands. For example, if I show you /bin, you'll see all those commands here, like mount, like s, and all the others. And these are part of the path command. So the path command is where Linux looks for executables. So if we can change the path command, we can change the command the program executes as root. So you'll notice that we can run this program as root. And what we'll do is we'll change the path command. So this is the output of the path variable. And let's just pick any directory, like the temporary directory. And what we want to do is, instead of executing the regular commands like the ls, we want it to open the bash prompt as root. So we'll make a file called ls like this. So that creates a file called ls which starts bin bash, and of course we need to make it executable. So chmod +x ls. Now we'll go back to the directory of the program, and you'll know that when we change the path variable, of course it will start the bash prompt, so we can no longer use ls. It's something to keep in mind. So now we'll update the path variable. So we'll type export path is /tmp, where we saved our ls command. So export /tmp colon the path variable. So that adds the tmp directory to the path variables. So if I output the path variable, you'll see tmp is the first place it's looking for programs. And in our case, we just made the program ls, which exists in that tmp directory. So it will execute bin bash. So now if we run the if I show you who am I, you'll see now we are user 1. And the program executes the ls command, but we just rewrote the ls command to be bin bash. So let's do sudo /test2, and now type who am I, and you'll see now we have root access into the terminal. So this exploit works by exploiting the path variable. So if you have an executable that can run as root, and it runs some commands, you can rewrite that command to start bash and take over the root shell. So this is the solution to this exercise.